In this section, we're going to take a brief look at TCP Intercept and uRPF. TCP Intercept having the router able to prevent against connection attacks, denial of service attack against devices. uRPF able to help prevent the device and prevent traffic flows of other spoofed addresses. TCP Intercept is one of the features we have on the router itself. TCP Intercept able to prevent denial of service attack against TCP servers, and some examples generally being a web server. Doing that by looking at the TCP connections and the initiated TCP connections. Now the default mode we have is intercept mode, the router itself acting as a proxy for the three-way TCP handshake. And we do also have watch mode, where the router just sits back and passively watching the connections, but still able to send out resets if problems occur. TCP Intercept has separate connection thresholds. We have what's called a 1 minute value, looking at the most recent minute in a rolling period. We also have the max incomplete value, looking at all the incomplete sessions being tracked on a device. Now for each of those two, we have the option of a high threshold and a low threshold. The high threshold is determining when we're going to enter aggressive mode. And once we're in aggressive mode, start being more aggressive with those connections, and we'll stop back into the regular mode when both of the low thresholds are crossed. So crossing either of the high thresholds will put you into aggressive mode. In order to stop being in aggressive mode and return normal operation, needs to be below both low thresholds. So with uRPF, looking at the traffic source information, where did this traffic come from? So normally, traffic comes into the router, looks at the destination, looks at the forwarding information for that destination prefix. In this case, taking things a step further, looking at the source. So looking at the source address and looking at the reverse path, what path would the router take to get to that network? Now different modes we have strict mode or loose mode. With strict mode, the path the router would have to take would be out that same interface, that same connection. With loose mode, just having a path anywhere out any interface except for a path that recurses to the null zero interface. So taking a reverse lookup and having that done off of the Ceph table, so it does require Ceph. And if it does not find a valid path, then uRPF by itself will drop the packet. It can also be used to prevent things like address spoofing, assuming you didn't have routes for those other spoofed addresses. Now uRPF being just another feature that gets checked on the packet processing. So different features being checked in different order of operations. In this case, looking at where that comes in when looking at just possible comparison with ACLs on interfaces. If you have an inbound ACL, that inbound ACL will be checked first, and then uRPF, after it passes that ACL check for the input ACL on the interface, uRPF check to see did the packet arrive on a best return path interface. Now with uRPF, it is aware of things like load sharing. So if you have two routes, either one of those routes would be valid. It is also aware of things like EIGRP with unequal cost, where you could have multiple routes of unequal cost. If it came in on any of those valid paths, then uRPF would be okay with that path check. Now general packet processing still have the forwarding table lookup, where to send that traffic out, and then checking against outbound ACLs on that egress interface, and then forwarding the packet on. Some of the additional items that can be done with the uRPF check, one of those would be adding on a ACL at the end, being able to have an explicit what to do for the uRPF, either to deny the packet if it fails the path check, or to explicitly permit that traffic even though the path check by itself fails. We do also have options for allow self-ping. By default with uRPF on the interface, not able to ping your router's own interface address on that interface, as well as a keyword of allow default. Do you want to allow matching of the default route, or without that, just expecting have a more specific route to match? So we took a brief look at uRPF, being able to stop address spoofing, and being able to do that by taking an additional path check on the source of the traffic coming in an interface. Also took a brief look at TCP Intercept, be able to have set connection limits, and looking at connections, TCP connecting through the device to other possible victims.